Hello everyone. Hope you are going through my previous lectures. Today we are going to talk about intrinsic safety. This is in continuation with the tanker safety lectures earlier we have discussed. Now in earlier cases we have talked about a tanker is a hazardous ship, what is a hazard, explosion, what are the requirements for explosion, the gas air mixture within the flammable limit, and energy source to complete the chemical reaction for explosion. And to avoid this, we have talked about the various EX protected equipment. Because best thing would have been on a tanker should not use any electrical system. So the chance of spark is not there because of the electrical system and circuit, but that is not possible. So we have to use electricity for various purposes on ship. So then we have to use it to safeguard against explosion. The equipments which we are using is EX protected. We have talked about the various EX protected equipment. We have talked about the zones, and we have also seen the suitability of the EX protected equipment for a particular zone. Okay. And then we have also discussed when we are selecting a particular EX protected equipment which is approved and which is certified for a particular gas in a gas group. So if we are using a right equipment, EX protected equipment, but for the right gas, then only, or for the right gas group, then only it will provide the necessary safety against the explosion. And in that we have also seen your temperature classification. That also is a requirement for selecting the right equipment for a particular gas atmosphere to avoid explosion. Now we are going to talk about the intrinsic safety. What is intrinsic safety? Safety against what? Safety against explosion. So what is intrinsic safety? The explosion will, for the explosion to take place, you require combustible atmosphere within the explosive limit or explosive atmosphere, and energy source. So energy source, we are going to see that the energy which is required for the explosion, minimum energy that is required for an explosion, if at all we have to use electrical equipment or electrical circuit, there if I ensure that even if some spark takes place because of the fault, then also it will not release energy enough to cause an explosion, then it will not cause an explosion. Or we'll take one example. Take the case of a tank of a tanker which is coming under zone 0, highly hazardous area, because there is always a possibility of these hydrocarbon gases being present, and the atmosphere can be within the flammable limit. So best thing is do not use any electrical appliance inside the tank which is coming under zone 0. But for monitoring purpose we are using some indicating instrument, monitoring devices that we are using. But then when we are using this, we are restricting the current flowing through the circuit. That circuit in that zone 0 should not exceed more than 50 milliampere at 30 volt. Okay. So if the volt increases more than 30 volt for any reason of the supply, then only as per Ohm's law the current will be directly proportional to voltage. So if the voltage exceeds 30 volt, then only the current will exceed, and in that, and suppose that time only some fault occurs, then the spark will be of slightly more intense because the current is more, and in that case what will happen? The energy release will be enough to cause an explosion if the atmosphere is within the flammable limit inside the tank. So intrinsic safety here is, we know that the atmosphere inside the tank will be explosive or within the explosive limit. We are also providing electrical circuit, and then we are assuming then that there will be a spark, and then also there means all three things are there, and then also we are guaranteeing that there will be no explosion that will happen even if some fault has occurred and the spark has initiated, but there will be no explosion because we are limiting the current to a maximum of 50 milliampere. Even if the supply voltage has increased, but then the supply which is coming to the highly hazardous area is limited by 30 volt, and then for 30 volt the current will not exceed 50 milliampere. So in that case there will be no explosion. Now come to that particular circuit. So you can go through this. Intrinsically safe circuit, voltage and current is limited to 30 volt and 50 milliampere, which includes the normal operation and specified faulty conditions. During the faulty condition, the spark will not release energy enough to cause an explosion even if the atmosphere in zone 0 is within the flammable limits. So this is intrinsic safety or ultimate safety. Now this is the circuit. Now we are dividing the circuit supplying to the hazardous area. See, this is going to the hazardous area part, tank of a tanker, and here we have provided that monitoring device, and we have put a resistance for resistance control the current. So if the voltage here, if the supply voltage is 30 volt, okay, then this 30 volt, if it is here, if I can maintain a voltage of 30 volt, whatever with the supply here, at this hazardous zone, if we can maintain the voltage of 30 volt, then as per the circuit resistance, the current will not exceed 50 milliampere. So the challenge is how we are going to maintain the voltage of 30 volt here, because we are getting the supply from the generation. We are generating our own power on board ship. So from there through the transformer we are reducing and getting the supply of 30 volt here. For some reason some fault has occurred and the voltage increases more than 30 volt. So if the supply voltage increases more than 30 volt, then what will happen? This voltage will, the supply voltage going to the hazardous area will be more than 30 volt. Let us say it is 35 volt. Okay, some fault is there, and because of this voltage increases and this voltage coming here is 35 volt. Then we also know that the current is directly proportional to voltage. So as the voltage has increased, more current will be flowing through this, and that time only suppose some spark that happens, some fault has happened. So there will be a spark, and now this spark is at a higher current. So this will release energy enough to cause an explosion. Now the main challenge is, whatever be some fault, whatever be the voltage here, even if it goes more than 30 volt, the voltage at the supply to the hazardous zone, that is zone 0, should not exceed. So here it is 35 volt, here the voltage still remains 30 volt. Okay, and for that we have got this circuit. Now we are providing the supply through the fuse. This is in the safe area, normally safe area, this is provided, and this is from the wiring that comes into the hazardous zone, which is zone 0. Now in the safe area circuit, intrinsic circuit, we are having Zener diodes. Z1 and Z2 are two Zener diodes, and this is a current limiting resistance. This is a fuse. The supply is coming through this. Now why two Zeners? What the Zener does? The Zener, see, this is the characteristic of Zener diode. So when we applied the negative voltage, and when we go up to, if the voltage is less than 30 volt, then there will be no breakdown of the zener and no high current will flow through. But even if when the voltage goes to more than 30 volt, negative 30 volt, then in that case what will happen? The zener will break down, a very high current will flow, but see, the voltage will remain at 30 volt. Okay. This is what we want here, 30 volt. So we select a zener diode whose breakdown voltage is 30 volt. Okay, reverse breakdown voltage is 30 volt. So if suppose for any reason, any fault, if the voltage here increases more than 30 volt, then what will happen? This zener will break down and a very high current will flow, but the voltage at this zener point, okay, will be 30 volt, and this is in parallel to the load, so this voltage will also be 30 volt. Okay. So whatever be the voltage rise here, the voltage will never exceed more than 30 volt. And to limit this, because this high current is flowing, so this to limit the current in the circuit, we use a resistance. So with the resistance, when the high current is flowing, it is limiting certain of the resistance, but still the high current is flowing. So this high current to flow, we provide it through the earth path. So a high current will be flowing through the earth path, but anyway high current, a fault current should not be there in the circuit. So we have provided a fuse. So when high current flows, the fuse will glow and the circuit will be protected. So here, through this zener, we are able to maintain the voltage in the hazardous area 30 volt, and if the voltage can be maintained to 30 volt, the current will be limited by 50 milliampere a maximum. Now why two zeners are provided? The two zeners are provided like we have got in boiler, because nobody wants explosion. So boiler, why we have got two safety valves. So if one fails, the other is going to operate. So here also we cannot take chance. We provide two zeners so that in case one fails, the other will take care of that condition and it will maintain the voltage of 30 volt, and in that particular time only if some fault occurs, then also the current will be limited by 50 milliampere, no explosion. So this is also important. The earth path is also important. You have to show in the circuit. Okay. So this is about intrinsic safety. Now this is the intrinsically safe circuit. It is important to show the normally safe area, because this has to be in normally safe area, and this has to be from this circuit. The lead wire will be taken and will be going to that zone 0, supplying to some of the monitoring devices. Okay. Okay. Now in case it so happens that one of the zener diode, some fault has occurred, zener diode, the voltage has increased and one zener diode has operated. So in that case, if we have to change, we will be changing both the zener diode. We cannot take chance. It might be okay, but we will not take chance. It may be stressed, so we will be changing both the zener diodes. Okay. So this is your intrinsically safe circuit. Hope it is simple, but it is important. We have talked about XI A, XI B, okay, and out of these two, both are intrinsically safe, but we will be using only EXIA, which has got the highest degree of the safety. So we are going to use EXIA in zone 0, which is highly hazardous area. So this is all about the intrinsically safe circuit. Thanks for listening. If you have any problem, if you have got any query, any doubt, then you can always ask me. Okay.